If you have any questions, you can ask.
Sir, I have a doubt on earlier session.
Yeah, what is the question?
Sir, what is random initialization trap?
Random initialization trap.
Yes.
How we select the number of cluster? We select randomly, right?
Yes.
How do we select the number of clusters? So we select
What, sir?
randomly.
Yeah. In step 2, we selected randomly.
Yeah. So we fall in a trap where there is a random initialization of the centroids due to the random selection of the clusters, right?
What, sir?
So see, the problem that occurs in the K-means algorithm in random initialization trap when the centroids of the clusters to be generated are explicitly defined by the user. Then inconsistency may be created because of the random initialization of the centroids. And this may sometimes lead to generating wrong cluster in the dataset. Suppose this is your data, and what you have done, you have selected the random centroid. And final model will look like this, for an example. 4 clusters are there. Second trial, you come up with the this solution, three centroids, or 3 clusters basically. We may get different model outputs on the same dataset. This condition, where a different set of clusters is generated when a different set of centroids are provided to the K-means algorithm, is consistent. Yeah, it makes it makes your model inconsistent and unreliable. So it is random initialization of the centroid or random initialization of the cluster. That's the reason it is called as random initialization trap. Right? Now, is it clear now?
Yes, sir. Yes.
Yeah. Okay. Now let us go with the yesterday's topic. So yesterday we just discussed this example. We have taken a data set and we are trying to fit the naive Bayes algorithm on that data set. Right? So yesterday we have done this thing and we just have discussed the count vectorizer as well. This is our count vectorizer. We have discussed the theoretical part on this. Now we'll continue with this same thing. We want to use the count vectorizer on SMS data, that is the original data. You want to fit the count vectorizer on that data. Just a minute. So count vectorizer on SMS data, we will do it. What we have to do is we have to create, first of all, restart and run all this. And next is we will do the same thing that we have done. CV is equal to count vectorizer. CV dot fit on this thing. So first is object creation and fitting the data. So let's take this out and we have to fit it on your data. So over here, your target variable is message. Sorry, label. Target variable is label, whether the label of the message is ham or spam. So target variable is label column and message is independent variables. X is equal to df of message and y is equal to df of label. Now we are going to fit this on your x variable because that is our message. We want to do the count vectorizer for this message column only, not label column. Now same thing we'll do. We will write down the words is equal to get underscore feature names. So instead of words, we'll just write down unique underscore words. Unique underscore words. Now we will write down this. We will convert that into array. So you can give any variable name, ABC, or let's say count is equal to array. And if you see what is there in your count, so this is your array, just like your count vectorizer that we have discussed earlier. Just like this thing. This is your array. Now, if we have to check the length of your unique words, so it's 8713. As this data is very less, the size of the data is very less, so you are getting only less number of unique words. But in our data, sorry, not value counts. In our data, we had 5572 messages. So you can imagine the amount of unique words that we'll get, right? Now this is your array, and this is your unique words. Now we have to convert that into data frame like this: unique words plus the array or matrix. How we can do is df underscore message is my data frame name, pd dot data frame, and I want to create a data. Data is equal to count, comma, columns is equal to unique underscore words. Df underscore message. If you check, these are your unique words. So basically, in message you had these words, so it has taken that as unique words as well as these words. So we have unique words now. Now we'll fit the model. So we need to go with the train test split x underscore train comma x underscore test comma y underscore train comma y underscore test is equal to train test split package name. Achha, we need to import the package for this. For train test split, the package is from sklearn dot model underscore selection import train underscore test underscore split. Now you'll call the package over here. In this we need to pass x, y, test underscore size is equal to 0.3 and random set is equal to, let's say, 3. Now you will use the naive Bayes. So in this case, as this is a text classification problem, we already have discussed yesterday, we have to go with the which type of naive Bayes? We have to go with the multinomial. For multinomial, we will require a package. We'll go to the official documentation and check how we can call the package. So this is your package for multinomial naive Bayes. Now let's do the model building part. In our model building, we create the object. So this is the object. Second step is we fit that object. Fit the model. Fit it on X train and Y train. Right here, we don't need to give X because X had the string column. We have to go with the df of message instead of X because this is our array. So df of message should be there. X and Y is not there. Yeah. what we should write is message. This is correct. See, here I have written the same thing, and we are getting the output. X-ray, X test, white and white test. X-ray, X test, white and white test. Train test split. DF of message, comma Y. It says 3 random state. Same thing is there. Why it is found input variable with inconsistent numbers. 7 rows, 8713 columns. Here also 5 rows. Okay, all right. Data is count, column is equal to unique words. Transform not message X into your this thing. Yeah. Now it will give us the output. nb.fit on X-train and Y-train. Now what is the third step? Third step is model prediction. So y underscore pred is equal to nb dot predict x underscore test. And last step is your model evaluation from a scalar dot model dot metrics import. This is your classification problem, so we will go with the accuracy score. And now if you find the accuracy of your model, it is 97.9%. Now if you have any questions in this, you can ask. Yeah, you guys have any questions in this?
No.
Yes, Jitu, Vishal, Vignesh.
No, sir.
All right, so Let us take a quick break of 3 to 4 minutes, and we'll start with the project part for Naive Bayes. All right, so let us let us start with the naive bias project part. So I'll create new. First of all, we'll require a file for this. This is your file and new notebook. Naive bias project part. So what is the first step? We go with the necessary libraries. So the first step is importing the necessary libraries. We import pandas as PD, import numpy as np, import matplotlib.pyplot as plt, input cmon as sls. And we will need to filter the warnings. So for that we have warnings dot filter warnings in quotes ignore. Importing the data. Next step is we'll import the data. Df is equal to pd.read underscore csv, and you have this data. Now if you check your head of the data, this is your data, but if you see, these columns are not proper. This is your entire row itself, or entire entry. So what we need to do is we need to write down header is equal to none for this. Right? So this is how you can do this thing. Now if I write this thing, separator is equal to comma slash s. If I don't give this thing, okay, and if I use this, what is happening? Comma. Now, what is our next step? We go with the EDA part, exploratory data analysis. So we'll check the shape of the data. We will check head of the data. Then we will rename the columns. Rename column names. Column underscore names is equal to, first column is age. Second column is work class. Third column is, this is what we have for the data set. So I'm also not aware about this. Fourth column is education. Fifth is education number. Next is marital status. Then next column is occupation. Further we have relationship. Then we have race. Then we have sex column. Then we have capital gain. Then what do we have is we have capital loss. Then we have hours per week. Then we have native country. And then we have income. Div.columns is equal to column names. I want to set my columns. So column names is equal to my df of columns. I'm setting this. And now if you check div.columns, find that age, work class, this thing, education number, marital status, occupation, relationship, race, sex, gain, loss, hours per week, native country, and income. If this is correct, what is happening over here? So we have 9 only. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why only 10 columns are there? Okay, we should not write this then. Yeah, we have 15 columns. Now it will work. Now if you check head of the data, the column names are changed. Now info. Now if you see, we have the categorical variable as well, categorical columns in your data. And we should go with the encoding for that. But if you see the data type of the columns which has object as their data type, they are nothing but your categorical column. So how to fetch this, how to view, or how to find categorical variables is categorical is equal to var for variable in df.columns if df of var dot data type is equal to object. Print. If this is happening, then print there are categorical variables. Next line, dot format length of categorical. print the categorical variables are comma categorical. D type is equal to object. So there are 9 categorical variable. The categorical variables are this. And if you check the head of your categorical variable, you dot categorical variable dot head. It's not working. Okay. Sorry, I should not write down like this. Div of categorical dot head. So this is a head of your categorical columns. And in this thing, our income is target variable. So problem statement is you have to categorize your data based on the income. Build the machine learning model which will categorize data into columns. Sorry, categorize data into different classes of income. This is your problem statement. Now, if you have to check the missing values for the categorical columns, is null dot sum. This is your missing value. So we can see that there are no missing values in your data. Now I am interested to check the frequency count. Frequency count counts of values in categorical variables. So for var in categorical, print df of var dot value underscore counts. So these are the frequency of counts of the values in your categorical variable for different columns. Now, what we want to do is for categorical column, we have checked this thing, null values sum is null. So we do not have any null values. Yeah. So next thing is we want to find labels for each and every class. So this is known as cardinality. What is cardinality? It means the number of labels within a categorical variable is known as cardinality. So a high number of labels within a variable is known as high cardinality. High cardinality may pose some serious problems in the machine learning model. So we'll check the cardinality. How to do this thing is for var in categorical print var contains comma length of df of var dot unique comma labels work class contains nine labels, education contains 16 labels, marital contains 7 labels. So these are the cardinality, means number of labels in within a categorical variable. So what is the conclusion for this is you can see that which column has highest label, high label, native country column contains relatively large number of labels as compared to other columns. And what we'll do is we'll check cardinality after train test split. Now explore numerical variables, that is continuous variable. So numerical is equal to var for var in df dot columns if df of var dot d type is not equals to object print there are numerical variables slash n dot format length of numerical print the numerical variables are numerical. So the numerical there are 6 numerical variables and the numerical variables are this. Now what we need to do is we need to view the numerical variables df of numerical dot head. Now we will check the null values. Dot is na dot sum. So there are no null values in our numerical columns as well. Now we'll declare the independent column and target column. So x is equal to df dot drop. My target variable is income over here. So I'll drop the income column from my x variable. So in my x, I have only target independent variable. So I'm dropping. That's the reason I'm dropping the target column. And in y, I have the target variable. Then we have train test split from a scalar dot model underscore selection import train underscore test underscore split x underscore train comma x underscore test comma y underscore train comma y underscore test is equal to train test split the package name, and in this thing we'll pass x and y. Test size is equal to 0.3 comma random underscore state is equal to 0. Now we'll check the shape of x train and y train. X underscore train dot shape. This is a splitting. What we need to do is we need to go with the feature engineering part. What is feature engineering? It is process of transforming raw data into useful features that help us to understand our model better. So we increase its predictive power basically. So xtrain dot data types. For categorical variable, display categorical variables. We'll write down this categorical is equal to column for column in x train dot columns if x underscore train of column dot d types is equal to object. X underscore train. So it will only print the object column, that is a categorical column. And how to display the numerical one? How to display the numerical variables is instead of object, we should write is not equal to object. That's all. Is equal to, it is not equal to. This is your numerical. And if you check what is there in your numerical column, so these are your numerical columns. Now for your hex train, hex train of categorical. Do we have any null values? Dot sum. So we do not have any null values. Now we will go with the encoding part, because we have categorical variable. We need to encode this. So I'll give heading as encoding, and we'll import category encoders. If this is working, then we'll use this C. But I hope this will give us the error. Yeah. So we have to go with the nominal or ordinal encoder. So we'll do this in next session. Yeah, you guys have any questions in this, you can ask. Yes, you guys have any questions in this? Yes or no?
No question, sir.
All right, so we'll stop here and we'll continue with the next session. So thank you and bye. Good night.